Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In the Nick of Time. Today with Zack joining us from Tetrate, the head of product, to talk about the future of service mesh and why this is so important to your identity management, next generation access control, and of course, zero trust implementation. So stay tuned. This is going to be a very interesting episode. If you have questions for Zack, do start asking the questions now because we have already about 15 questions or so. Please do that in the comment section by starting with a Q. Also, if you want to share you're here with us today, just put your name and your company so we can highlight you on the screen. And then finally, here is a reminder for everybody to subscribe to the show so we don't depend on LinkedIn. Will to share the dates of the show to you guys. So in the nickofTime.tv, you're going to get an email per week on our new videos and content coming up. So check that out at in the nickofTime.tv. Of course, wanted to remind everybody, Learn with Nick is here now. We are crossing the 3,000 subscribers, 4,000 subscribers now. So check out the 50% off for military civilians and veterans. And give us updates on the content and what you see there, what's missing, what kind of new video you would like to see. In fact, we just released this week. You'll see this video on Istio, which is very good timing for this discussion today. So if you don't know enough about Istio, the service mesh, and you want to catch up and go from 0 to 60 with Tetrate, check that new video on learnwithnick.com. You'll see about 2.5 hours of great content on service mesh. So that's our latest video that came out just this week. Now, I wanted to remind everybody we have this new store in the nick of time, store.inthenickofTime.tv. All profits go to the Fisher House. So check that out. We have fun t-shirts and different goodies. So if you have ideas of new design, let us know too. We're looking for new design for next month. So let us know. And like I said, all profits go to the Fisher House Foundation. So 100% of them. Now, wanted to also remind you that Monday we're going to be launching our Cloud Native Town. In fact, that's going to be used for the big event that Rob Slaughter and the Defense Unicorn team are setting up with this 3-day event on Introduction to DevSecOps, where we're going to have a full industry day with dedicated rooms with different companies and different topics, Air Force, Space Force, you name it. Platform One will be there. So check it out. We're going to make this big announcement on Monday, and it's going to be free to use. Anyone can go on the metaverse and engage with the teams. And we have telcos, banks, healthcare companies, 7 nations. So it's going to be a lot of great content, new videos every week, completely free to use. So you'll see that pretty soon. If you want to get a kind of early access to it, you can go to cloudnative.town. Cloudnative.town. I'll put it on the screen so you can check it out now. It's still getting finished, but it's good enough for you to play with it. So go check it out. I'll put it on the screen in a second so you have the link. Cloudnative.town. So it's gonna be fun. Completely free to use, and you'll see the Industry Day will be a lot of fun too. So you'll find a lot of great content: Service Mesh, DevSecOps, Kubernetes, SRE, SLAs, SLOs, you name it. And then every company out there on the CNCF stuff, from HashiCorp to Data2IQ to Red Hat to Aqua to Docker to Rancher to Tetrate to Acorn, you name it, Elastic. A lot of great companies on there sharing their content, sharing their releases, doing events to announce their new features. It's going to be a great community to keep up and make sure we don't get behind. So this is going to be great. All right, so let's see. Zack is going to join us in a second, but I want to do a good job because Zack is an exceptional person. Not only he does not have my ego, which is as big as the Empire State, but Zack is getting things done. Is really the founding engineer behind Tetrate, but of course behind Istio at Google during his time at Google is helping now drive the product decision as a head of product at Tetrate. Like I said, he was the earliest engineer on the Istio project at Google, and he sits as the committee elected representative on the project steering committee. He's written and he's been helping NIST for many years now including as a co-author of the NIST special publication 800-204A. If you and B, of course, if you've missed those, go check them out. He's working on a new publication now. He's going to tell us a little bit about it today. Before, of course, Tetrate, Zack was at Google on both Istio and across the cloud platform at Google. And you'll see that Zack really understands where the future of this service mesh discussion is going to go to, and is going to lead the way to get us there with him, so we can understand effectively what to do and when to do it and what to pay attention to. It's a very fast-moving environment, so I'm so excited to have the chance to have Zack here with us. So let's bring him on the screen. Welcome, Zack.
Hey, thanks for having me. It's a pleasure to be back.
Yeah, so that's the second time for you on the show, but this time we're going to be focusing on, the future, what you've been working on for the last couple of years. We did kind of tease about it a little bit, obviously, when you came on the show last time, but this is going to be a deeper dive, and people are going to be able to really see what it takes to move at the pace of relevance. It's not easy. For people that missed maybe the last episode, love for you to give a little bit of your background and your journey, so we can get into the real meat.
Yeah, definitely. And you did a good job of I think giving at least a high level for folks. So I started as a software engineering. I went to a student at Auburn. Went and started working for Google right out, and was privileged to be able to work on what wound up being a lot of the core systems in Google Cloud, the central resource hierarchy, the identity, and access management systems, the service management, service consumption systems. And before that, I actually got to work in really classic enterprise for Colonial Pipeline Company. So it's kind of funny that I now get to write the security standards, or help write security standards for the federal government, because a lot of that was actually spurred by the Colonial Pipeline hack and the executive order that followed a few years ago now. Like you mentioned today, I work with Tetrate. We're really all about taking the service mesh to enterprise and to really large, complex, heavily regulated environments, like the DoD, like large financial institutions and similar. And out of that, I get a lot of experience to help write a lot of these SPs that help inform service security. The goal is hopefully, these are a little bit more grounded and realistic, and maybe a little bit more readable, if you don't mind me saying, than a lot of the SPs that we normally see. We tried to make them a lot more approachable and hands-on than a lot of the guidance.
Yeah, and they're also moving at a faster pace, and I think they'll suddenly, summarize to the point, so we don't end up reading 500 pages for something that could be done in 20, right? So that's good. So
exactly.
All right, so let's talk about zero trust a little bit. We had a guest on the show 2 weeks ago, actually, about zero trust and the debunking of what it is. And obviously, a lot of people have different opinions there. What is your take on it? What is zero trust?
Yeah, so we see so many different takes. There's a ton of FUD in this space, right? It's actually kind of frustrating as somebody that's like trying to maybe do it the right way. So what is the right way, and what do we see around zero trust when it comes to runtime? So first off, there's a few different kind of places where zero trust comes up. I would argue there's an entire pre-runtime activity. The software supply chain, your GitOps, your Git processes, your code review. What does it take to produce an artifact? All of that is pre-runtime. Really important. We're seeing the emphasis in industry today on software bill of material as one of the ways to grapple with parts of this problem. Where I spend most of my time is on the runtime, and I think this is maybe the most important part. You need to know that your binaries are good and coming from the right place, but fundamentally, when it comes to the runtime, there's really 5 things I would argue that you need to be performing. And if you're doing these 5 things at every single hop in your infrastructure, not just at the perimeter, then I would argue that you've achieved a zero trust posture. And those 5 things are: 1, you need encryption in transit. So you need to make sure that people can't change the message or eavesdrop. Two, you need to be able to authenticate service identity. So what is the application that is communicating? Three, you want to be able to authorize on that. So it's not good enough that it's just that you have an application identity. It needs to be authenticatable at runtime, and we need to be able to use that to apply policy. Then four, we need end user authentication. So we need to know not just what is the application that's doing the communication, but who's the user in session, right? Maybe one way to think about this is, it's not good enough to know that the Twitter app is on the iPhone. We need to know that Nick is the one that's tweeting, right? Is maybe the way to think about that. And then, the fifth thing is that end user action. So authorizing the end user action at every hop along the way. And note that may be a different action. On the front end, there's one action, but that translates to a different action on the back end, which translates to yet a third action on the database. And at every hop, we need to ensure that is authorized to occur. So those five things: encryption, service authentication and authorization, end user authentication and authorization. And if you're not doing those, then you're probably not in a zero trust posture. Microsegmentation doesn't do that. No single product probably today does all five of those as well. So you're looking at assembling a set of different pieces together to achieve that capability. Certainly, obviously, you can probably tell I'm a little biased coming from the service mesh side. So the service mesh provides strong capabilities to do at least four of those five, with extensibility to be able to do end user authorization as well. But we need all five of those to happen every single hop, not just at the front door.
Yeah, and I guess I have my couple of extra ones that I like to think about. I don't know what you think about the device enforcement piece, but for us in DoD, obviously very important to know the device identity being used and see
100%.
who is behind it, like you said. But what's your take on the device piece, I guess?
Yeah, that's critical. So I kind of hand waved and said service identity. But if we dig
Right.
into service identity, that's really gets to the heart. There's two things that you want to be able to check when you issue a service identity. One is, what's the application that's executing? And two is, what is the environment in which it is executing? Right, that device. So is the device trusted? Is it is it a machine that's on the DoD network in a secure facility somewhere, or is it a cell phone that somebody has out in the world? Is it coming from China or Russia? Is it coming from the US? We want to be able to do all of those things to make a risk-based assessment when we issue the credential, and hopefully we're using that to scope then the privilege in the system. So, maybe you do get privilege to log in from Europe or from Russia, but certainly you can't write anything, and maybe you can't read nearly as much, right? Device identity and that authenticating where an application is executing is a critical piece of that.
Yeah, and I was at a great meeting with the DoD CIO Zero Trust team, and they've been working on this great publication that's going to come out on Tuesday. By the way, people need to check it out, which will be listing the 150 something key pieces of a puzzle to be able to get to their target zero trust architecture. Obviously,
Awesome.
there's a lot of things. I think it's always a little bit bloated. That's okay, right? They have seam and saw and a lot of different things, right? That to me, I guess what it starts to look like is your entire cyber posture now is like zero trust, right? So it's always a struggle for teams. I find that it's so bloated nowadays that effectively you're telling people to do zero trust. You have to do all these cyber posture things that you're supposed to be doing anyways. You mentioned the SBOM stuff, but of course there's continuous monitoring pieces in logging, centralized logging, telemetry, right? All these things, right? SIEM, SOAR, and whatever else. I guess, how do you make sure that is that with your five things that you say, hey, that's the boundary, I guess, of zero trust versus a bloated zero trust strategy?
Exactly. So to your point, there's a lot of other pieces. That five is really the runtime. So SBOM and how do we get a binary and all that stuff is important and does need to be addressed. Right. Now, is that essential for zero trust or not? I would argue, even if you have a legacy perimeter-based security model and you're happy with that for your business, you've done the risk, you understand the risks involved. that software supply chain and software security and the CI/CD pipelines and all of that is still valuable, right? So I view those as two categories. So
Right.
having the assurance in the software that is running is important and critical regardless of your security model. Then when we're adopting zero trust itself, we can focus on a lot narrower set of things at runtime, right?
Yeah.
So, and even those 150 I'm sure include things like inventory and there's a lot of other things
Yes.
besides that goes into understanding your overall security posture, right?
Right.
They're important from a runtime perspective, though. At minimum you need to be doing those five things, and if you're not, if you're doing those things, then you're probably a zero trust, but maybe not. But if you're not doing those things, then I can almost assuredly say you're not.
Right. I guess, do you recommend people to maybe rename, instead of calling this a zero trust, strategy? Is it more like a modern cyber architecture strategy? That's, instead of making
Yeah.
zero trust bloated.
Yeah, exactly. That's I actually hate the name zero trust in general. I think it's actually a giant misnomer. It is correct that you don't trust the network, but instead, I would argue that the entire communication is trustful rather than being network oriented, which there is nothing to trust, right? We're instead using PKI and those established cryptographic primitives as our basis for establishing trust. So yeah, I think in general, zero trust specifically as a term is over bloated, and then what it becomes to government or what it becomes to these other large organizations is yet again a different animal. And that's why I really try and pare it down to five really simple things that like any engineer, any developer, any manager can understand, to be able to take and go, did I implement these five things or not? Didn't, there's got to be some gap somewhere that I did,
Is
like
is
something
there
is.
is there a single document for them to go and get that list and be able to really understand what it means? Because obviously terms can be interpreted in different ways. What's the
Yeah.
best way for people to do that?
Yeah, so today there is not a single authoritative one. There's a couple different guidance documents from different agencies. CISA has a cloud native, or a cloud security architecture document, for example, that covers a lot of the essentials of zero trust as well. DISA has some guidance in this as well. So there's a few different places. One of the ones we're going to talk about in a little bit later in the show is an upcoming 207A, where hopefully those five that I just described to you, we will codify into SP as like a real simple litmus test.
Right.
Today, there's a gap and it's spread out, and that's why shows like this are super important. Is and Larry, that's exactly right. Zero implicit trust, I think, is exactly the right thing. We're really making the trust in the system explicit. That's spot on.
Right. Right. All right. So I guess the question on the from the audience on Twitter, I can bring it up on the screen, but I'm just going to read it to you. You mentioned encryption, right? We had a lot of great discussion on the show about quantum risk and the new generation of crypto. Obviously, there's different impact between symmetric and asymmetric crypto.
Yeah.
Is there any concern for you when it comes to obviously service mesh in general with quantum risks coming from this new wave of ideally quantum proof crypto?
Yeah. So, I guess there's a couple different things to pick apart here, right? So, from my perspective, I am not any more or less worried than anybody else that has to run something that does encryption, right? So the general philosophy from the service mesh world is that we're gonna continue to build the software using the best known available cryptography in industry, right?
Right.
Today, we base the FIPS distributions of Istio that Tetrate builds on boring SSL, which is
Right.
widely deployed, very well understood.
Came
It's
from
in
Google,
the
right?
CMDP database. Exactly, yeah. Google. It's the Google SSL libraries, right? Um, as and when the standards shift to include quantum cryptography and concerns there, and I'll note that NIST is like actively running competitions right now on quantum cryptography. So as those evolve, those will be included in that software, and the service mesh will have the ability to use hardened algorithms,
And
right?
I guess back.
Uh,
Oh, sorry. Go ahead.
no, go ahead, please.
I guess back to Kelly's comment here with everything as code. How important is policy as code when it comes to the management of the settings of the mesh?
It's key. It's key. Like I would argue, that everything is code is exactly right, and we want policy as part of that as well, right? And when we talk about policy, by the way, it's not just security, but the traffic management, the observability capabilities, traffic routing, and failover, in addition to access control. Do I allow or deny this? Those are all types of policy that the mesh can implement. We want that to be code for all the reasons you want everything else to be code. It should be it's
Right.
declarative configuration. We did a bunch of work to make it declarative. You want that source of truth to be able to go and understand what the ground truth should be.
Right. Makes sense. Makes sense. All right. So now we talked a little bit about next generation access control.
Yeah.
What is it exactly, and can you describe it to the audience?
So this is actually where you mentioned, and we talked a little bit about, I write SPs with NIST. Actually, my relationship with NIST started in researching access control. I also mentioned, I worked on GCP's identity and access management as well. So when it comes to access control in industry, ABAC, attribute-based access control, is the gold standard. For folks coming from the cloud native world, you're probably familiar with stuff like Kubernetes RBAC. RBAC is a phenomenally powerful system, but it has well-known limitations. ABAC is an extension or another formulation of access control that's fundamentally more powerful, but with power comes responsibility, right? And so RBAC is a very tightly defined system. ABAC, you can make the rules. The problem is you have to enforce the rules, and enforcing those rules is very challenging in practice. Next generation access control is trying to kind of be a best of both worlds, if those are the two worlds. The idea is we want to be able to express any kind of policy. We want to be able to write anything that we could write with an ABAC like XACML. We should be able to write with next generation access control in GAC. But there is we want some bounds. We don't want it to just be the wild west of you can put attributes anywhere, and policy works on a set of attributes, and you hope that you got it right. And so what next generation access control does fundamentally is move to a graph based model for modeling the underlying access control. ABAC is traditionally formulated as a set, and it brings us some rules along with it. And so it has some rules on how the different parts of the system can relate. The net of this is that we get an access control system that performs faster than traditional ABACs. It has the capability to explain and audit accesses. So I can tell you that Nick was able to hit the record button in StreamYard because he's a member of this group, and that group has this entitlement on this container and that container, and this shows a member of that container, right? And so we can walk through the set of policies and the set of containers for objects and for users to explain and understand in human readable terms why an access is allowed. So fundamentally, this is super exciting. It's really hard to understand access control policy at scale. So having tools inherent in the system to do this, big win. The other big win is that fundamentally we want to do what I just described when we talk about zero trust. We want to do authorization of the services communicating and the user to resource or the user action in the system. When we talk about service communication, that's fundamentally a graph. It really makes the access control policy in the system a lot easier to be able to model a graph in a graph, right? Where we have an access control system that's graph based. We have a real world access problem that's inherently a graph. It fits very well. So not only does NGAC provide a lot of really awesome capabilities, but it fits the problem domain that we are trying to solve very well. And so it's a really powerful tool. I firmly believe, and by the way, Dr. Ferriolo, who created it over at NIST, is famous for having created RBAC. He is the guy. If you go read the RBAC paper, you go read the RBAC book. Author number one is David Ferriolo. He also helped create ABAC. And so NGAC is kind of his magnum opus. It's his final kind of contribution to society at large before he retires, with the express goal of beating out and sunsetting all the existing ABACs, because it's just a better way to do it.
Yeah, and definitely with him, being involved in this is kind of the next generation. That's the name, in fact, of Allback, right? And I guess that's
Exactly.
why it's called the next generation access control. But he's such an exceptional person, right? That's done so much for the nation and security as a whole, and he's
He
such
is.
a great person. So I'm excited that we have the two of you to make sure we come up with something that's going to make sense, right? So I guess next generation access control. So I know when we talked about it last time, right? You were still writing a lot of it and kind of creating
Yeah.
the right implementation strategy. And I know you've been working on pilots and trying to finally put this
Yeah.
in real deployments, right?
Yeah, we're actually super excited now. This latest release of our product actually finally uses NGAC in the service data path. So we've actually been using NGAC for years to implement an identity and access management system very similar to GCP, with a hierarchy, with permissions, with inheritance down the hierarchy, really sophisticated stuff. And so we've been using that to harden next generation access control and build the engine, build the core APIs, and you know ensure that it's actually functioning. We're actually just now moving from having it on the management side, user access, to pushing it into the service data path, so that every single request goes through an NGAC decision point. We're super excited about this. We've seen really, really good preliminary results. The reason, or the use case, and I'll give this as a teaser, this will be a following NIST SP, or at least a white paper that'll come out, not 207A, but a little bit later. One of the reasons we are putting NGAC in request path is to allow for higher level identities. So right now, if we think about writing identity-based policy, that's a big thrust of zero trust. We're writing really, really primitive identity-based policy. In fact, I compare it, and all the time I compare the service mesh back to the legacy generation of networking. And so if we look at the things that we built at L3, L4, the service mesh is rebuilding a lot of those at the application layer, but for the application layer. So it's not a re-implementation, but it's a leveling up. And so if we
Right.
think about network policy and IP policy, what did it look like? Originally, we wrote like policy with IP addresses and with CIDRs, right? And we up leveled into talking about subnets, and eventually we up leveled into label based network flows, right? And we
Right.
use label based policy to control ABAC. Fundamentally, label based policy is an ABAC we use to control network traffic. Today, when it comes to identity based policy, we are writing IP addresses and CIDRs, right? Like we're writing individual service account names. One of the things that will happen in the next 2 or 3 years is that we're going to up level that to be higher level groupings. So the reason NGAC understands the notion of a service and even units above a service, like a workspace that's owned by a team that has many services, we allow those to be used as a principle in a policy rather than like a runtime service account name. This even further enables a policy to move across environments because it moves with your notion of a service, not just with your notion of even that service's single runtime identity.
And
So you can have, so I can have it in AWS and in GCP, and they can have two different runtime identities in that place, but one policy that says front end can call back end.
So to answer Douglas, I guess it's completely independent to the infrastructure.
Exactly.
And it could be on premise,
Exactly.
could be a gap, could be disconnected. It doesn't even have to be on the cloud. In fact, it could be anywhere.
Exactly. So if you think of like the GCP or AWS access control systems, they are attribute-based access control systems that look like RBAC. You create a role, you assign that role to users. Under the hood, they're an ABAC. Think of NGAC as another way that Google or Amazon could implement their identity and access management systems, right? So that's the level to think about it at. There are companies we're working on it. There's other folks that are working on the commercialization of NGAC. For us, it's a longer term thing because we're focusing on the service mesh right now. So you will see NGAC start to appear more and more over time. Think of it in the same way that you think about RBAC. So it's a way for you to express policy.
So I guess, a lot of people were asking what the difference between RBAC and ABAC and LBAC, right? Because a lot of people use these different
Yeah.
terms. Roles obviously
Yeah.
assigned to users, labels can be assigned to data users and whatever. What's
Yeah.
the difference with attributes? Attributes could be labels. I mean, so what really, how do
Exactly.
you explain it, I guess?
Yeah. So I think of it like this. So attribute-based access control is kind of the granddaddy. It is the most expressive thing. So if we think about it from a mathematics perspective, because fundamentally access control is an applied math. And so, we think about the instantiations and the engineering project of building NGAC, but understanding NGAC itself is fundamentally applied math. So when we look at it uh, there's a couple different pieces that are essential to understand like how it's different from RBAC and ABAC. RBAC itself is set based, and it defines three primitives. It defines a primitive. I apologize, the puppy is barking at the mailman.
You have a cute puppy, so that's okay.
Yep. It defines a role. What is the set of actions that a user can take? And then you bind that to a resource. So users' resources get bound to a thing, right? ABAC is the granddaddy. It can express anything. So any RBAC policy that I write can be modeled as a set of attributes.
So I'll take a question that someone asked here. Let's see. Nick, can you expand on your concept of pace of relevance? I guess what's important for me when it comes to the pace of relevance is to say, hey, how do you compete in a world of speed and baked-in security and things like that? And that's really where we need to think of not only the velocity, but also what kind of technical debt do you get? What kind of impediment you have to your velocity. It could be security driven. It could be a lot of different things. So we think of it as kind of this a critical foundation, right? You cannot build software in a vacuum. You have to use DevSecOps, baked-in security, and things like that. And that's what enables you to move at a pace of relevance. And the pace of relevance is effectively what is the difference between being in business or getting slowly behind and a lot of technical debt, and at some point having to stop work to tackle that technical debt, or just effectively go out of business, right? So, and you're back. So here we go. I took a little question.
Sorry about that. So again,
sorry.
Fundamental question was, what about ABAC, RBAC, NGAC? What are they different? How are they the same?
So I guess how do you separate? Because I have a tough time separating ABAC and LBAC.
Yeah. So think of ABAC as the most powerful one. So any access control system that you could choose, you can implement with ABAC. So it's super powerful, but with and again, that's why it can be unwieldy and hard to use, right? RBAC, when we think about RBAC itself, it's a much more constrained problem. So with RBAC, rather than being able to assign any kind of attribute or label to any kind of user, instead we restrict what can be done, and we say, hey, there's a predefined set of nouns that a user can have. So rather than saying I can assign any set of attributes I want, and then I'm going to write a policy that targets 3 or 5 attributes, instead in RBAC we say, hey, there can only be a doctor and a nurse.
But what about labels? I guess my bigger question is, what about labels, LBAC and ABAC? Yeah. That's the one
basically the same thing. They're basically they're at least as far as I'm sure that there might be some technical distinctions between the two. From a language and spec perspective, there's a small difference. When we talk about how you conceptually think about it, it's the same. An attribute is just a label. A label is just an attribute.
Right. So I wasn't completely crazy.
Yeah, exactly. That's the easiest. Again, there's some nuance in the details, but at a high level, just think about it in terms of labels are attributes, and
roles are more like singular. You can't usually you don't have more than a couple of roles at best. Or
exactly.
It's not like labels where you can have more granular labels and very precise things, right? So
exactly, and that actually gets at the fundamental heart of the expressivity. That limit of you only have a few things in RBAC is the reason that it's so successful. It's really easy to understand mentally. Like
Right.
I can read a set of policies and I can imagine successfully most of the time what access is or is not allowed by the system. When you get to a label-based access control or an ABAC, it's much harder to understand what is or is not allowed by a policy change.
In fact, didn't you have some work on the explainability of labels and showing
Exactly.
that visually? Is that a piece of the puzzle there?
That's exactly it. So that again gets to the kind of fundamental math side. So the math that underpins these systems, RBAC and ABAC is based on set theoretics. And the thing with a set is that it's flat. There's no notion of causality or
Right.
necessarily a relationship between them. Whereas a graph it can be built from sets, but a graph has a notion of causality. I have these edges that link things that imply some direction or movement. And so using those edges, we can walk through the graph. And basically, when we're making an access control decision, can a user act on an object? We're going to walk the graph from the user to the object, and we're going to gather some permissions along the way. And again, I'm being very high level here, but and those permissions then are the actions that you can take. But those paths through the graph describe user understandable policy, right? They
Right.
say, hey, Nick is a user and Nick is a member of the admin group. And the admin group has a policy that gives right permission to this project and your resources in that project.
Yeah. So
That's
it's
a
like
path
that's the
that
whole
you can
concept of
read
a
out of the
graph, right?
graph.
Showing the relationships and the which is tough to comprehend, right? If you have a lot of cross
Exactly.
pollinating things. Yeah. Interesting.
Exactly. And so you can show that graph to a user, or you can give out a text description like I just described to you, and the
Right.
user can use that to understand. One of the other big capabilities is that we can do that ahead of time. So I can say this is what it would be if you were to apply this
Right. If you
policy.
give that label, that's yeah, the
Yeah. And
impact.
so you can exactly. So you can do impact analysis exactly.
Funny enough, maybe 5, 6 years ago, I saw the company that was doing graphs in cyber to be able to show hidden relationships between like someone signing a contract and a partnership agreement, and then also being responsible for the cyber assessment, and you also have all these findings in CVs and things, and you will see like relationship between companies,
No, that's very cool.
offices, clouds. It will show you like hidden relationships, and
Yeah.
so I sold this thing and it was at the time pretty unique because the graphs you couldn't really handle massive volumes, and we were the first to use at the time neo4j to
Oh,
get
that's
to
awesome.
that kind of volume. So
That's
I
awesome.
understand
Oh,
the
here.
concept of relationships. That was a nightmare in my
Yeah.
life for a year. So
I bet. I bet. No, that's all. And just actually, by the way, you might want to revive that company or spin out another one.
I know,
I
right?
expect that the exact same thing is going to happen for SBOM. So
Right.
it's going to be important for us to
Dependencies
understand the
and
graph of software
right
dependencies and software libraries that
licenses.
we depend on, because
Yep.
there's linchpin pieces, right? So like if, for example, the service meshes were successful in becoming a modern security runtime, then that means that Envoy, the proxy that we use to implement all the policy enforcement and encryption and similar, that's a linchpin security component for a large part of the ecosystem. A
Yeah.
more obvious example is OpenSSL is a
Yeah.
linchpin security project for the entire world, right?
Right.
I think as we dig into SBOM and SBOM matures and tooling comes into existence that does some of that graph analysis, we're going to see some like pretty disturbing things. I think
Oh yeah.
in I say that with a smile, but like I expect that we're gonna see some things that we look at and we go, wow, that's really not sustainable as an industry.
Oh yeah.
Or hey, we need better investment. So I think that'll be an interesting outcome of SBOM maturing, that kind of graph-based analysis.
Yeah, I've asked so many companies and products now, first with the Air Force, and even after helping companies try to do business with DoD, I was still surprised, even with pretty well known startups, pretty good teams, they had dependencies that were older than the company. you
Yep.
know,
Yep.
and I'm like,
Exactly.
how did you pick a version that's actually older than when the company was founded? Like how, and these
Yep.
new versions, right? And I'm like, how did that happen? Like, how did you get stuck on that version.
Exactly. And that's where we need, just like we need better education around zero trust, this is an area where we need a lot more concerted education across the board for folks
For
on,
developers, right?
managing dependencies and the
Yeah,
importance
picking them.
of
Yep.
dependencies for security and
Updating them. For some reason they get stuck in
yeah.
time forever, right? So that's really
Yeah,
bad.
exactly. Yeah, you never update them. Yeah, exactly. And so, this is where, things like on GitHub, the security, the dependency scanners and some of those things that are being rolled out are, awesome for community-wide impact in somewhere. So, it's exciting to see as an industry we're increasing the level of maturity there incrementally. I wish it would go a little bit faster, but it is at least refreshing to see that, we're kind of moving in the right direction, it feels like.
What kind of technology are you using now for graphs? Is it is Neo4j still relevant, or is there something better now?
Yeah, so we actually use a little bit of a homegrown thing today for NGAC for a variety of different reasons.
I thought there was a bunch
The
of open
shortest thing,
source things now. I
yeah.
guess there's
What?
no.
No, sorry.
I thought there was a bunch of open source capabilities nowadays. Isn't
There
it
are
not good enough?
so Neo4j is still great. It would be the one to pick as we get into larger and larger data sets with NGAC. We will likely start to use Neo4j as our backing store. Today, though, actually, we can get to really large enterprises using a really simple in-memory graph database.
Mm,
We basically implement a set of adjacency lists, and
right,
NGAC graphs tend to be pretty sparse.
right.
And so with an adjacency list, we actually get pretty good. We can actually fit like millions of records on a single, pretty modest like developer laptop for testing kind of a
Right,
thing.
right.
So we have large scalability in the system to meet the needs today without needing to go all the way to a heavyweight graph database, which has
Yeah.
different problems like get a license for Neo4j clustering,
License, you have to pay.
and those kinds of things. Yeah. So for us,
I
it's
got
more
a few
tackling
million
the system.
nodes on Neo4j. It was getting pretty slow.
Yep, exactly. So so there's a bunch of different trade-offs. For us as well, there's some interesting kind of secret sauce and special things we want to be able to do with the graph that we can't really do with Neo4j. What I mean by that is, we have the service mesh, we have sidecars to do enforcement. I would like to be able to do enforcement locally in the sidecar and render
Mm,
decisions there to the extent possible. It doesn't really make sense for me to put Neo4j on the sidecar,
yeah.
but a simple
No.
in-memory graph database we can. So that's what we use today for practicality. In the long term, the system will likely be a mix where you'll have Neo4j or some other kind of source of truth backing database with
Right.
enforcement happening with decisions happening locally in the proxy as well.
Interesting. All right. Very cool. So I guess let's talk about the NIST 204 series, right? Tell
Yeah.
us first, for people that don't know the 204 series, tell us a little bit about the 204 series and what have you. And I have a link here at the bottom of the screen where you did a great blog on the Tetrate website. So if people Google Tetrate NIST standard for zero trust, you're going to come up with that page here. Tell us first about the 204 and then what you've been working on.
Yeah. So the 204 series, so just to back up one, so for when NIST itself, they produce special publications that are, recommendations that are binding in the Department of Commerce and used by the rest of the government and industry as authoritative standards. There's a bunch of different series there. 207 is one that a lot of people are familiar with. That's what defines zero trust. 853 is the one that everybody has to implement for FedRAMP. Uh,
And
204,
not just FedRAMP, but all FISMA and
everything.
control.
Yeah, like 50. Yeah, 853 is the granddaddy. It's the big one.
All the controls.
Um, exactly. All the big controls. 1189 of them last time I counted.
Right.
204 is the set of standards for microservice security. So full stop. Right now, there are 4 entries in that series. There's 204 itself, which is a very high level document that outlines about 13 different strategies around microservice security. 204A is the first one that I helped author, and it gets more specific and it's really laying out the groundwork for a secure service mesh deployment. 204B, excuse me, then builds on that to talk about using that secure service mesh deployment to secure applications running on the mesh. Right? So we had to kind of build up. So deploy a secure mesh itself, then use that security property to secure applications running on top of the mesh. And so 204A describes a variety of security properties that the mesh can provide. And it also talks about, although it doesn't directly say those 5 things that I call zero trust, it exactly talks about how the service mesh can be used for encryption, for service authentication and authorization, and end user authentication as well. And so we directly speak to those. And we even talk about actually the relevance of NGAC in modeling the graph access and using it for access control. 204C itself is the last entry in the series today. And it is specifically about the pre-runtime activities and about the SecOps pipelines. And so it's about, secure CI/CD pipelines and similar.
I think I helped on that one. I forgot which one.
Yeah, you
But
did. Yeah, we there a lot of your stuff definitely fed into it as
I forgot. Too many numbers. Too many
Yep,
numbers.
exactly. So 204C exactly was based on Platform One and a lot of the work that you spearheaded as part of the DSOP. What's coming up next is a couple different ones. You mentioned pace of innovation is going up. At the same time, the pace of standardization here is going up as well. I'm actually pretty proud. I think the 204 series is maybe about 5 years ahead of time compared to when NIST typically standardizes around a set of technologies. So I'm really proud that we are relevant in a timely place.
Yep.
As the federal government is adopting, it's already there. What's coming up next then is another probably 3 to 4 SPs in the next year or so. So quite a lot is coming, and it'll be coming in 2 different series. So the first one that I am really excited about, I kind of view 204 has been setting the groundwork. We've been kind of defining the baseline, and now in this next 2023, we're going to start to come out with some SPs that really kind of do cool stuff. Now, basically, they use the groundwork that we've laid to really talk about how can we move to a zero trust environment, architecture. How can we enable these, So to that end, 207A will be coming out next year. It is exactly about transitioning from a traditional perimeter-based security model to an identity-based posture. And we're going to specifically talk about some patterns that we see used in the wild to do things like deploy an identity-aware proxy on either side of the DMZ when I want to facilitate, for example, communication from cloud back to on-prem. And we can have a static set of firewall rules that allow these 2 sets of pools of proxies to communicate. And then we can apply, application level identity based policy for who can go over the tunnel. The advantage in a world like that is that we still maintain our perimeter security model with the DMZ, but we've made the policies there static rather than having to change them every time an app wants to consume a different SaaS on cloud or a new app gets deployed that needs to call back to the database on-prem. And instead, when those new things happen, we write an identity-based policy in the service mesh that's much easier to understand, that's much faster to author, that we have those NGAC techniques to understand the impact of the policy change and similar, so that we can have confidence to make the changes more quickly. So that's what 207A will discuss, is this migration from a perimeter-based model to an identity-based model, and some example reference architectures that we'll look at for how you do that migration. Then following on, there's a whole bunch of other stuff that kind of needs to be addressed in the periphery. One of the things that we're going to address is that notion of identity that I talked about earlier. Today we're writing, service account oriented, like individual runtime identity, IP based, effectively, the equivalent policies. We want to up-level the policies. We'll have a white paper from NIST that describes, why we want to do that and what good looks like. We'll additionally have some follow-on, probably another white paper or recommendation at least around the service mesh sidecar deployment. I think that's one of the topics we'll talk about in a little bit here, Nick. But we'll talk about eBPF and sidecar and ambient and all of those. We're going to write up some formal analysis of the security trade-offs of those deployment options and some guidance on where you might want to pick which when. And then finally, there will be a 204D is likely to follow on as well, continuing to build out some of the runtime controls that the service mesh can provide for applications. So it'll be a pretty packed year, I think, with quite a few SPs coming out. Hopefully, all of these are really short, concise, and pretty easy to read. 207A, we're really hoping will clock in at about 15 pages. So really short and concise compared to 853 that's 400-page document, something like that.
Yeah, lots of controls, of course, but so I guess a lot of the discussion around zero trust with companies, they are arguing that it's mostly about identities, right? So a lot of people that do identity proxies and stuff like that argue they have a full-fledged zero trust product. We talked about your 5 pillars of zero trust. One of my important stuff that I always talk about is micro-segmentation, right? And software-defined perimeter and kind of removing the ability of a malicious actor to scan the network to see what's there and have a dedicated segment of one to only be able to see what they're supposed to see based on the device they 100%. Use, the identity they have, and the component risk of those 2 factors that can be continuously reassessed along the way. So you can continuously assess the state of the device, patching state, and malware and other stuff, and the user identity as well. So what's your take when it comes to micro segmentation? I don't think NIST has done a good job yet to define what the software-defined, we talk about software-defined networking, but not really software-defined perimeter. So what's your take on the SDP / micro segmentation side of things? Do we not talk enough about it?
Yeah, so I view it as a pretty important defense in depth. I think in general, it's probably not talked about enough about. However, we still want to, the general pattern or strategy that we've seen, or at least that I have seen, has been relaxing those controls in favor of identity-based controls. So the idea is we want to reach a steady state where we have the defense in depth. To your point, you don't want somebody, just because you have authentication and authorization at every hop, doesn't mean somebody should be able to map your entire infrastructure with port scanning because it's all internet facing, right? So 100%, you still want these perimeter controls. From my perspective, the important thing is balancing them to be able to maintain agility. Because that's really the problem that we see, is not that those controls are not good or people want them, but keeping them up to date, keeping them accurate is challenging. Understanding why those rules exist is challenging, and so then they become brittle and slow and kill agility. So I think they're important. I think we need to talk more about how you can do better practices around layering in that way. The other thing is, I think there's some technology that needs to happen. So right now, there's a huge number of duplicate policies that exist in the stack. So if you think about, for example, like 2 microservices calling each other that do those 5 checks that I described to you. So that's 5 ACLs, 5 policy decisions that we applied, right? So we encrypted it, we authenticated and authorized at both levels, but there was also quite a few network ACLs that we went through. Right, so we did have some VPNing, some subnetting, something there. There might even be some firewall ACLs and similar that we went through. There's a bunch of different policy at different layers. From a technology perspective, I believe what is needed is a little bit of a higher level system or a higher level language to describe services that need to access each other. That should be instantiated automatically by some machine at the service mesh layer, at the CNI or SDN layer, at the cloud provider VPC layer, at it. You know what I'm saying? So that's where I believe. Exactly. We should be able to express an intent. There is, and actually, by the way, this is another interesting one. I think the way that we're expressing policy today is fundamentally wrong. We're doing pairwise, like front end can call back end can call database. What we really want to be able to say is there is a user action from the front end through the back end to the database that is exactly, the update shopping cart. And that calls, the put on this one and a put on that one and a post to the database. That's a flow that I want to ACL. Or that, sorry, let me rephrase. I want to create a policy that captures that flow and no other flow. And then I want to translate that into a discrete set of policies that the mesh can enforce. For example, hey, front end and it can call the back end. Back end can call the database, and only on these methods. But the high level policy should describe this graph, basically, and not even a full graph. It's actually, in the telecommunications world, what's called a slice. So this slice of end user exposed function through my system. And there's some ACL, there's some permissioning that's involved there. And then, in my opinion, that's the holy grail. That's the best possible policy that we could write. Not just front end can call back end, the back end can call database, but this is the end user flow. And there's 6 of them for this set of applications, right? From that, we should instantiate a microsegmentation. We should instantiate a mesh-based, identity-based policy and similar. We're not there yet today, but that's, in my opinion, where we need to go.
Doesn't it get quite complex when you have a lot of microservices that do different things, and you don't really have a good understanding of how to describe it, the whole flow, I guess, because the flow might change.
Yeah, that's one of the reasons it's not done. I won't say impossible today, but not done today, is because the rate of change is large and accelerating. And so what you actually need, I believe, to be able to do that successfully is tooling to feed back into your policy engine. So you need something like the service mesh that can observe real-time traffic in the system, use that to generate policies, have humans approve those policies and promote them into production. And that should happen in a continuous feedback cycle as the applications evolve.
Interesting. Very cool.
And again, it's a tooling problem today. There's not that feedback loop there today around policy authorship because there's not a common policy enforcement point and common telemetry out of the system to be able to build that. The service mesh starts to provide that. So I believe that, in the next few years, we'll realize that as a system. And I say I think in general, industry is like getting to the point where all the pieces are in place that we can realize that.
Yeah. I guess someone was asking on Twitter, if you use a mesh and you don't have any other kind of cyber mechanisms, does the mesh prevent kind of the lateral movement in the sense of scanning, not maybe interacting, but scanning the network in terms of discovery? Or you still need other mechanism, like you said, maybe subnetting or whatever it is you're going to do?
So there's a couple different things. So one, you are depending on the non-bypassability of the sidecar there. So like if I can figure out as an attacker how to bypass the sidecar, then all bets are off and you can do the scanning. Now, so let's take that out. So let's assume that you can't break out of the container, break out of the sidecar. Then there's really the question is, do you program your service mesh correctly? Is maybe where I would put it, by which I mean, by default, when you install Istio, for example, and all other service meshes are the same as far as I'm aware, it sends total service discovery information everywhere, right? So in some sense, you can map the network because you could even just ask the proxy, what is all of your configuration? And it would tell you, everything that exists in the network and where all the endpoints are. Or if you don't want to be proxy aware, you can just start sending requests and the proxy fundamentally has the configuration to be able to route to them. Now, hopefully you have an authorization policy in place that would reject it, but that still means that I can map your infrastructure.
Right. Yeah, because you could still find it, right? You can still discover it.
Exactly. So in what I would call a properly configured service mesh, in addition to having authorization policy, you should scope the configuration that goes to any individual sidecar proxy instance such that it only has the configuration to route to the set of services that you need to talk to. In other words, the configuration for what you can talk to should align with the authorization policy for who you're allowed to talk to.
Right.
instead of knowing how to talk to anybody, but authorization policy says I can talk to this set. I should talk to this set, and I should only know how to talk to that set. When we can do that successfully, then you've limited the space that an attacker can move laterally to only the intended backends that your service should be talking to. So there's still an element of discovery that's allowed, but it's contained.
It's a smaller attack surface.
Exactly.
But just to clarify, because there's a difference between discovering and being able to engage with the service, right?
Yeah.
And have some type of interaction. I guess
exactly.
With a mesh, could you prevent, if you set it up right and you have the enforcement mode on, can you prevent the discovery of non-whitelisted services?
Yes.
So they wouldn't even be able to find out if it exists.
Exactly. Now, again, that will depend on what instance you land on. So, so let me give you a concrete example. Tetrate Service Bridge uses Istio. That's our flagship product, uses Istio. We program the discovery information in the sidecars based on your access policy. So the access policy is exactly the set of things who you are allowed to talk to. We use that to send the configuration so that you're only configured to discover those things. Mm-hmm. Now, when you compromise it, you can, let's say that the front end can call the back end. If I compromise the front end, I can discover the back end, mm-hmm. but I cannot discover the database.
Right.
And so so you can't sit on, it's not like you're getting a bastion and you can like network scan everything around you.
Right.
You can only pivot to the things that policy explicitly allows you to. So we've reduced the attack surface. We bound our attack in space to only the services that you're expecting that application to communicate with. That, by the way, is then why the super policy that I described that moves across multiple services is mm-hmm. so much more effective for bounding an attack in space, because it's not just front end can call back end, but it's like only this method of the back end and only from this spot in the front end. You can start to just ratchet down the space that an attacker can move in more and more effectively. By the way, one other piece here. That's why it's so important that you authenticate and authorize the end user credential in addition to the services. That's why all 5 are so essential, is that it's about bounding an attack in space and in time. So a service can talk to the backend, but if I additionally have a policy that says only in the presence of a valid end user credential with the read scope, then I've again narrowed the attack surface. So it's no longer sufficient to own my front-end server. You also need to then own end-user credentials in session that are valid and not expired, and they need to have the right scopes. So now you need both of those to then pivot and attack the backend. So it becomes substantially harder for an attacker because you're bound by application and end-user identity and session. So you're bounding in time based on the expiry of those credentials. End users, that's typically 15 minutes. For service identity, that's typically an hour. Mm-hmm. So we get that double. So you have like 15 minutes to perpetrate an attack before you need to reseal a credential, and you can only attack the backends and not anything else, right? So it gets us into a much better state than a lot of enterprises have today.
Yeah, short-lived certificate, so important, right? Although people keep storing credentials in plain text in Git, so that might not be a good idea to do that.
Yeah, and in the Kube API server and similar, like don't put secrets in etcd. Like please use the secret, use the storage interface driver to load secrets securely. Like there's a bunch of easy foot guns that are in place to leak secret material in cloud native systems, right? So that's why a lot of those pre-runtime checks are equally important for a zero trust posture as the 5 runtime checks, right? So you can't, if you're leaking secrets, if you put the cert on GitHub, then it doesn't matter what your posture is, because I can act as your service, right? That's why both are essential.
So I've been fighting for this for many years, and finally Istio was donated to the CNCF. So tell us a little bit more about that.
Yeah, so this was super exciting. It's many years overdue. I think Nick, you and I both talked about it back in the day about how frustrating it was that Istio
Yep.
wasn't in the CNCF. It finally is. So it's accepted as a project in by the CNCF, just like Kubernetes or Envoy or any of those other cloud native projects that you use. Previously, the real change here is that the CNCF holds the trademarks, whereas previously Google held the trademarks.
Right.
But all the other stuff that comes along with being in the cloud in the CNCF, Istio gets now as well. So we're super excited. Materially, probably the single biggest impact you'll see out of this is one, that's the CYA. I kind of joke that the CNCF is the new IBM. Nobody gets fired for installing cloud native technology. You have that check mark there for Istio itself. But the more important thing is that it's finally in that neutral body, so that I think we'll finally start to see kind of all the cloud players come in and participate in the space. I think basically that this unlocks Istio finally becoming what Kubernetes was for container orchestrators, right?
Right.
By which I mean kind of putting to rest the battle of like Mesosphere versus Kubernetes. Today we have Istio or Linkerd or Hashi or whatever one. I think that we will see over the next year convergence on Istio as it already is the industry standard for serious enterprise, but I think we'll see it converged on as the industry standard across the board.
And what status is it in? Is it graduated, or what's the status?
Nope. So it entered just like any other project. So it entered as an incubating project. I do believe we already satisfy all the criteria for graduation. However, we have not yet applied for graduation yet. We do intend to. We're working with the CNCF TOC for guidance on when and how to do that. I don't materially, I'm not sure how much of an impact that makes for decision makers or not.
Well,
It's in the CNCF. It does. Okay, great. So that is something we are actively.
I hear a lot of 14500 say they don't do anything if it's not in production if it's not graduated, I guess. So.
And one thing I will say, of course, is that Istio itself, for decision makers that are watching, I know you have a bunch that watch this show, Nick. Is Envoy itself is the thing that's actually doing all the policy enforcement, that's handling the bits and bytes of the application traffic. That is a graduated project. That is a project that has FIPS builds and similar. So that's the thing that's really handling.
Istio definitely check all the boxes, so we should get it done.
Exactly.
Move on.
Exactly.
Yeah.
Yep.
Yeah.
Yep. And so Envoy does. Istio itself, the control plane that drives it, will be. Hopefully, all of that to say, hopefully it'll be graduated in 2023. I don't know of any blockers that would prevent that from happening.
Yeah, I doubt so. And for people that don't know, Envoy is the proxy used by Istio, and Istio is kind of the control plane of the mesh.
Exactly.
All right. Let's see. Now, I wanted to. In fact, I'm going to take a question here.
Yeah, I was going to say that's a perfect question.
Yeah, how expensive would it be to implement a service mesh in a startup or any small and medium company, or does it make sense only makes sense for large corporations?
Yeah. So I think that thinking about it in terms of company size is not quite the right dimension. Right. So the service mesh, the real capability or the real benefit that the service mesh brings is that it's a force multiplier. So really what I mean by that is it becomes an integration point that works horizontally across every application. So, for example, and this is regardless of if you're a small company or a large company, let's say that we want to move into a new market and we're subject to PCI or whatever other regulation, right? That means we need to up our security. So how are you going to go and implement, for example, encryption in transit that's required there? Do you go to every application and implement encryption, or do you bring in the service mesh and do it in one place?
Yeah.
Now we need to operationalize our applications. We need metrics, we need logging, we need tracing. Again, do you go to every application or do you do it one time in the mesh? And
Yeah.
now we need to add in canaries and failover capabilities, retries and resiliency again, right? So the
Yeah.
question is
I
not
guess
how
for
big
any
is the
software intensive company, right? It's a no brainer to enable and scale their teams and have to not focus on building all this stuff in a vacuum, right?
exactly. It's really about so for small and medium teams, I would say it can be a really effective force multiplier,
Right.
so that there's a whole litany of concerns you don't need to deal with. In practice, the most mature service mesh adoptions today are in large corporations.
Right.
That is because we're still early in the adoption curve and it's still hard. And where there's a bunch of folks, Tetrate included, actively doing work to make service mesh adoption easier and cheaper. So that horizontal multiplier is most attractive the larger you get, right? If you have 10,000 applications, it's intractable to add encryption in transit. But if you have 10, you could, right?
Right.
And so certainly the value proposition is bigger the larger you are. But even for a small company with a small focused team, there's a lot that you can offload and just don't do in your applications if you can have the mesh do it.
Particularly if you care about security and zero trust and don't want to build all this tech debt, right? That's, I think, the biggest
Exactly.
win for scale. And many
Exactly.
teams, of course, could buy stuff as a service and uh, avoid to build it in a vacuum and leverage PaaS services, right?
Yep. Exactly. And even when we're leveraging, PaaS and SaaS services and similar, we still have our core business applications that we got to run, we got to secure, and we have to manage how they communicate out to the SaaS, right?
Right.
And so even there, the mesh provides a lot of value regardless of team size. So again, I don't want to sound overly rosy here. It's definitely an expensive thing to adopt. It is most beneficial for large organizations. But thinking about it as a function of size of deployment is wrong. Think about it in terms of people and the horizontal multiplier. What is the effort of implementing X feature across every application in the portfolio? And what's the incremental cost of doing it every time you bring a new application versus doing it once? And what we see there is that at least in my opinion, it makes sense even for small folks to start with a mesh or to begin to use one.
Right. Right. So I guess back to our question, how do you go after deploying the service mesh across a large organization?
Yeah. So we start incrementally. So first off, it's not gonna happen in a snap, right? It's a long process, it's incremental. What we recommend that we do is first inventory the set of applications that the team is gonna deal with. Right. And that could be all the applications in the infrastructure in the organization. That could be a very small subset that are only going into Kubernetes, for example.
Right.
Then once we have our set, and for most people, I like to work with the entire set of applications in the infra, not just Scoop. We then bucket them, and there's a bunch of different criterion that we use for bucketing. There's a service mesh handbook that's on the Tetrate site. I think you maybe have to give us your email to get it. In that, I have a 3-page checklist that I go over for what we do to onboard an application and how we bucket and similar. The high points are we're going to bucket by how the application communicates. Things that are HTTP go in one bucket, things that are TCP go in one, things that are UDP go in another. Then we're going to sub bucket by framework. So things that are let's pick all the Java Spring Boot apps first. And the reason for this is they're going to have behavioral similarities. And then eventually we're going to narrow down that bucket so we have a handful of applications there that are maybe and then we're going to start with the easiest of those. So let's pick already containerized HTTP applications running in Kubernetes. And for most organizations, that's like a tiny, minuscule number of things that really aren't business impactful. But we can start there where it is easiest to deploy the mesh and demonstrate value. And then we start to move into harder buckets of applications. And when I say harder, I mean because they have more rigorous runtime capabilities. It's a more critical application. It has more stringent security or availability or reliability requirements. Or it only speaks TCP and it doesn't speak HTTP. So we're going to run down that list, onboarding applications and learning every time that we do. Because the goal for large organizations that I work with primarily is to build the blueprints and to build the happy path for development teams to come on and bring their applications. And so we can do that per type. Here's the happy path for Spring Boot. You're taking a Spring Boot application off PCF that has Spring Cloud Gateway, you're moving it into Kubernetes and cloud. It's already network oriented, it's already containerized. Here's the recipe. And now you have, what was a PCF app is now a Kubernetes service that you have the mesh to route with, for example. And then we go down to the next pool of applications. And so we work that, in the way that you would expect. Kubernetes, containerized, web-oriented, down to TCP, UDP oriented things, and then off of Kubernetes and into VMs, into bare metal deployments, into DMZ deployments and similar. So we kind of move from the easy part out to the edges of the system, and from the easy applications into the harder ones.
Interesting. And what about legacy, I guess? By legacy, I mean, real legacy, like 60-year-old, SCADA systems, or can you, or maybe just also, non-Kubernetes centric universes still running on, on-premise vSphere or whatever.
Exactly. Yeah. So we do see. So that's one of the key things that Tetrate actually has extended the service mesh to do. We have customers with large footprints in vSphere, in somewhere. When you work with financials in the DoD, if Kubernetes suddenly stopped existing, right? If every single kube cluster shut down, most people wouldn't care, right? And what I mean by that is the critical systems aren't there yet. And so if that's the only place that you're providing value, it's not good enough. And so for us, it's essential that you are able to go back to VMs, that you're able to go back to legacy hardware. And for things that you can't literally put a sidecar behind or in front of, there's a variety of other techniques that we have, whether that's deploying an egress proxy in front of that network appliance that can apply policy on behalf of the service mesh, or just modeling it as an external service that we route traffic to. There's a lot of techniques that we have kind of in our toolbox for integrating existing systems with a sidecar, without a sidecar, and incrementally getting visibility and policy control.
So is it more like a proxy setup then, and you put something in front of it, or how does this work?
Yeah, that's one of the techniques for it, for sure. So we see, we see deploying a sidecar on the bare metal on the VM. That's one option. The second option is a traditional kind of reverse proxy deployment, right, where that Envoy middle proxy can apply policy. A third one is, what you might think of as like a squid egress proxy deployment, right, where we can apply policy as the request goes out the door.
Right. Interesting. So I guess Joseph here had a question.
Yeah, that's a great one.
Linkerd wasn't really hard to set up, pretty easy. Is Istio much harder? What does the pain come in, and is a pain getting it into Kubernetes to begin with? I think the other piece is also, it's not just the setup, and it's how you set it up, and the enforcement mode, and whitelisting of resources, and I think it's pretty easy to install. They want any mesh, but then doing it right is a whole other story. In fact, Linkerd at the beginning did not even have the enforcement mode for a very long time, so that wasn't even an option. So
exactly. So Linkerd, so let's level set here. There's a couple different things to tease out. So where does the pain come in? 100%, a lot of the pain that users experience is just, I'm new to Kubernetes and I'm doing service mesh at the same time, and it's all really hard. So that's definitely part of it, right? However, to your point, like Linkerd actually does quite a few things to optimize the day zero install setup experience over Istio. And there's a variety of different reasons for that. They pick a different, easier set of defaults to be able to bring to the table. They didn't do encryption for a long time. They do that now. So they were able to do a variety of things that eased over some of the initial Istio adoption hurdles. However, today, in a modern Istio deployment, we do most of those things too. So I think if you're looking at a fresh install today of both Linkerd and Istio, Linkerd is likely going to be marginally easier to get up for the very simple hello world getting started. Istio shouldn't be too much harder, but there might be a little bit extra. One of the other areas where there's more complexity to Istio is that there's a lot more resources that are defined. Right. There's a lot of so when you install it into Kubernetes, there's more custom resources for Istio than there are for something like Linkerd. And that's another area of that complexity, the surface area that I have to think about or learn about from an API perspective. That's again both a function of Istio's greater breadth of features, as well as the fact that Istio is intended to be used by multiple personas. And so I would never expect any individual developer to write, all 20 or 30 of the Istio CRDs. I would expect an application dev to write 3 to 4. I would expect the security team to write 1 or 2. I would expect the platform team to write 1 or 2, right? So that's the other place where we see perceived complexity, or maybe even legitimate complexity, because Istio doesn't make it clear maybe what those lines of ownership of the configuration should be.
Interesting.
So hopefully that answers. I see you're replying back. Glad this is helpful discussion. Hopefully this kind of answers a little bit of the question there around some of the setup pain and like against other meshes.
Yeah, good point. All right, so let's look at eBPF versus sidecar now, right? There's been a big discussion. There's this new concept, I guess, with eBPF. What can you first tell people what eBPF is and what's the difference with the sidecar model?
Yeah, so eBPF, Berkeley extended Berkeley packet filtering. Ooh, that's a tough one to say 10 times fast. Is basically think of it as a VM that runs inside the kernel in kernel mode. It executes a restricted language called eBPF. And there's a bunch of hooks throughout the kernel to the eBPF runtime. So think of it as almost like a JVM or a restricted JVM that's in the kernel space that can execute a custom program that you provide without making a context switch to user space. So that's baseline what it is. Now, in the kernel, there is something called the Express Data Path, XDP. The Express Data Path is a set of hooks in the network stack for eBPF programs. And so what this does is let us offload a variety of functionality that we would normally do in a user space proxy. We can write as an eBPF program, compile it into that intermediate format, give it to the kernel, and the kernel can execute it for us without a context switch into user space every time a packet comes in. So when we think about the sidecar and what the service mesh is doing, encryption, per packet and per request policy, then it is obviously very attractive to look at eBPF as a way to accelerate that, or a way to maybe implement a lot of the functionality instead of a sidecar. So that's the baseline, what eBPF is. Now, where does it come into the service mesh discussion? It primarily comes in with isovalence Cilium mesh is where a lot of the kind of, I'll say FUD has come from, right? This idea that it's eBPF versus sidecar. And you can either have a sidecar in user space and it's slow, but you have the full set of capabilities, or you can have eBPF and it's fast, but there's some stuff that you have to fall back to an envoy to be able to do. That's the dichotomy that has been created via marketing. That's fundamentally wrong. So it's not an either or dichotomy. Instead, I would really push people to think of eBPF as an accelerator. eBPF is a way that we can take an existing capability, like dropping a packet because it came from the wrong IP address or whatever the policy is, and pulling it out of the user space envoy and into the kernel. The key thing to understand, though, is that eBPF is working at L4. You can't, because so it's a, I mentioned it's kind of like the JVM. It's kind of not like the JVM in that it's very restricted. So loops, there's a fixed loop iteration. You can't have unbounded looping. You can't have a variety of other types of things. The result of that is that an eBPF program is decidable. So we can kind of sidestep the halting problem because it's not a full Turing complete programming language. The downside is that you cannot do things like parse an HTTP header in eBPF. It's really hard to do L7 policy if you can't do basic things like parse the L7 protocol. And when I say really hard, I mean it is literally impossible. Therefore, something like the Cilium mesh model uses eBPF for the L3, L4 capabilities. And then they deploy an envoy on the host to handle the L7 capabilities.
But it's a node. It's a daemon. It's not a sidecar.
It's on the node. Yeah, and so I would never recommend anyone do that from a security perspective. You have a confused deputy, you have a noisy neighbor problem. There's a variety of different problems. I already mentioned earlier in the call that with NIST, we'll be doing a write-up analyzing the security trade-offs of the EV plus node-based proxy versus a sidecar per application proxy versus ambient, which we'll talk about in a minute here as well. So again, I want people to understand it not to be either or, but think of it as and. Instead, what I would recommend is, eBPF should be used to accelerate some of the capabilities that we go to user space proxy today. Any decision, any packet that I can drop through an eBPF program before I do a user space context switch to hand it to the Envoy sidecar is a net performance win for the system. I saved the buffer copy, I saved the context switch, I saved the Envoy processing time. You're looking at something that could happen on the order of a quarter of a millisecond as opposed to like 2 milliseconds, right? So an order of magnitude improvement in performance in the limited cases where you can reject a request using only the L4 capabilities, right? So there's big opportunity to be able to go a lot faster, but the set of use cases where we can do that is limited. So I would suggest that people think of it in terms of offloading capability from a sidecar into eBPF, but you're still going to need a sidecar. And then you can get into the discussion of like, do you put the sidecar on the node or do you keep it per application? Cilium Mesh is putting it per node. Istio is keeping it per application. I think you should never put anything that works at L7 shared on a node. You're asking for shared fate outages and other problems. So, I think that the end state that we're going to wind up with over the next maybe 2 or 3 years in the service mesh space is it will have a combined eBPF plus Envoy data plane that will be deployed per application. And that will be the kind of normal consumption model for the mesh.
Yeah. So you mentioned ambient, right? That's another concept that came to be as well. Tell us a little bit about what it is.
Yeah. So ambient mode in Istio is yet again another deployment model. So we have the sidecar model. I have an application running, and in the same trust domain as the application, I deploy a proxy. In Kubernetes, that means they're in the same pod. On VMs, that means I put the Envoy on the same host in the same VM as the application itself, in the same trust domain. That's because fundamentally the sidecar is presenting an identity on behalf of the application to other things on the network. So it makes sense if you're assuming my identity, then you might as well be in my trust domain. The downside of this is that there are a lot of proxies, right? So suppose I deploy like 30 pods on the same host, or I have a large physical host and I have 10 VMs on it, for example. That means that I'm running like 30 envoys in the pod case or like 10 envoys on the VM case. Is there a way that I could run less envoys but still get the capabilities? And I want to run less envoys to be more resource efficient, to have hopefully simpler operations in the system, to just simplify things. So ambient is exactly trying to do that. And so what it does is it kind of goes halfway. If we think of Istio on one side with sidecars, we think of Cilium mesh on the other side with a host-based envoy. Ambient goes right in the middle. And what it does is it puts L4 shared on the node, but it deploys a dedicated L7 proxy per service. So the idea is that the L4 part of it, the encryption, the identity, and that bit is shared by everything on the same host. But the per request policy, the L7 capabilities where you have the biggest attack surface to cause shared outages is still dedicated per application. So it's trying to cut a middle ground between having a sidecar dedicated one-to-one, which has resource overhead and waste, and the Cilium model where it's all on the node. And that's efficient and fast and lightweight, but it has bad security properties. So the idea is, can we get a happy middle ground? And so the thought is, shared L4 is safer than shared L7. So that's maybe okay to share. And then we can have dedicated L7 proxies that we route to transparently that implement the sidecar behavior. So the intent is to try and get kind of a middle ground, best of all worlds, where it's a lightweight resource footprint, the security properties are good, the performance, the operational characteristics are good, but it's lighter weight than a sidecar. In practice, I expect that in security first environments, we're going to continue to see the sidecar for the foreseeable future. There's a blog post that we have on Ambient that maybe Nick, if you can link, I think I had sent it to you previously. If not, I'll dig it up. That discusses the trade-offs between Ambient and sidecar. Again, if you're security first, I expect that it's going to be sidecar. In general, please don't use Ambient in production. Like, oh my God, it is not ready. It's not, it is still experimental. Basic things like security are not there yet today. Basic things like how does it interop with CNI is not well defined today. So ambient mode in Istio is not yet ready for prime time. But if you want to like kick the tires on in a Cayenne cluster on your local machine, have at it, right? It looks promising. There's resource savings. There's potential for performance that's really interesting, but not ready yet. We will have in the next year a write-up from NIST that analyzes the security trade-offs in detail of the three models of sidecar, the Cilium mesh shared L7 model, and the ambient shared L4 model.
Very cool. So I guess it leads me to my last questions, where obviously you shared a lot of great information here, but people have a tough time keeping up. And how do people learn all this? So what are your tips for learning, I guess?
Yeah, I think one of the best things that you talk about is the importance of investing in yourself and your career, right? So, one, there's, of course, on your training site, there's, Learn with Nick, there's some preliminary mesh content. There should be more stuff that's arriving from Tetrate there in the future. Secondly, there's academy.tetrate.io. And there is a ton of really good material. If if a lot of what we talked about sounded interesting today, but you kind of got lost in the details or not familiar, there's free training there on Istio, called Istio Fundamentals that go over what Istio is, what the capabilities are, what it brings. There's free
And it's the
training
other
on
way around,
Envoy.
right? It's academy.tetrate.io, not
Yes, Academy. Oh, did I say it the other way?
You said it. You said you said academy.io, but here we go.
Oh, whoops! I'm sorry. Yes, thank you, Nick, for correcting me there. Academy.tetrate.io. So free Istio and Envoy training. There's additionally some workshops like the 0 to 60 workshop. There's also paid Istio certification if you're interested in that kind of thing, and in professional certs to kind of progress your career. Finally, that same free Istio training that's on academy.tetrate.io is also on the official CNCF training site. So we announced during KubeCon Detroit a few weeks ago that we donated that training material to the CNCF, as part of Istio's submission to the CNCF. And so that on EDX, I believe, is the site that the CNCF uses for all of its training. And so the Istio course that's there is from Tetrate as well, and is should be valuable. So all of those are great places to go. Additionally, and the last one I'll mention is the Tetrate blog has write-ups on a lot of this stuff as it happens. So if you're curious about ambient mesh, Nick linked in the chat the ambient mesh blog post. There's a whole lot of other blog posts and content there around the space and changes in the space. So that's a great place to keep up. Academy.tetrate.io is a great place to go learn more. Come in, ask questions and go from there, and we can kind of help guide folks in progressing.
Yeah, so first of all, wanted to thank you, Zack, for coming back on the show. This was such a great session for people to know what's coming, what's the future of service mesh, why it's so important for people to pay attention to what's going on, both for their velocity and also for their cyber posture and implementation of zero trust and streamlining all this nightmare, how to learn, how to keep up. That was awesome. We're going to give you the last words, but I wanted to remind everybody of the next episode. So next Tuesday, 1 p.m. Eastern, the 29th, we have a great guest again, Greg Tuhill, director of the U.S. CERT, former and first federal chief information security officer, Fed CISO of the United States of America. So he's going to join us. He's also a former DHS and Air Force general in the Air Force as well. So he's going to share with us a lot of his journey and what he's learned and kind of see where the future of cyber is going. And so it's going to be an interesting discussion, particularly now with his role in the CERT, which is so important for keeping track of vulnerabilities and CVEs and threats and all that good stuff, and where people need to focus their time to defend their cyber posture. So there's going to be a great discussion next week, and we'll give the last words to you, Zack, and wanted to thank everybody again.
Yeah, thank you everybody for spending time. Thanks, Nick, for having me on. I appreciate it. A lot of fun having a discussion here. If anybody has any follow-on questions or anything else, feel free to reach out to me on LinkedIn or Twitter. Or even GitHub if we're in some of the same projects. I'm Zack Butcher on all the social media. So definitely feel free to reach out, ask questions, or anything else. Thank you, and thanks for taking time today.
And thanks, everybody. You stay safe. We'll see you next Tuesday, 1 p.m. Eastern. And in the meantime, keep up the good work so our kids have a fighting chance at winning against China 20 years from now. Stay safe, everybody. Bye-bye. Have a happy Thanksgiving.